All right. Hi, everybody. Welcome to today's webinar, Teaching Data Science, with authors Jeffrey Saltz and Jeffrey Stanton. This webinar is presented as part of our Sage Talks series, connecting you to influential authors, one webinar at a time. Now, before we really begin, we have just a quick poll we'd like you to take. You should see it in just a minute on the screen in front of you. We'd like to know, how familiar are you with data science? You could select your answer. This kind of information is always really helpful to us. Love to get to know you as we go into the webinar. Give you just another few seconds to answer here. You can probably close that out. And what do we have? Okay. Well, we have a mix. Always makes it tricky, but we're up for the challenge. So we have some folks who are somewhat familiar, some who are just starting, and a handful who are pros already. Well, thanks so much, everyone, for filling out that poll. That kind of information is always great. Helps us to get to know who's on the other line. All right. Well, let's get started. I'm pleased to introduce our speakers today. Jeffrey S. Saltz is currently an associate professor at Syracuse University in the School of Information Studies. His research and teaching focus on helping organizations leverage information technology and data for competitive advantage. Jeff holds a BS degree in computer science from Cornell University, an MBA from the Wharton School at the University of Pennsylvania, and a PhD in information systems from the New Jersey Institute of Tech. Jeffrey M. Stanton is a professor of information studies at Syracuse University. Dr. Stanton's research focuses on organizational behavior and technology. He earned his PhD from the University of Connecticut, and his research has been supported through 18 grants and supplements, including the National Science Foundation's Career Award. Today's one-hour webinar will be recorded and archived for future viewing. We'll be sending out a link to view that recording in the coming weeks. If you have any problems with audio or viewing mode during the webinar, please use that Q&A box at the right of your screen, and one of our helpful team members will get back to you ASAP. At the end of the webinar, we have some time for Q&A, so please also use that Q&A box to ask any questions to our speakers throughout the webinar. Please also take note of the hashtag SageTalks and feel free to ask questions or leave conversations there. In today's discussion, we will be talking about integrating data science into your course or program. You'll leave with a sense of course objectives, tools for doing data science, and sample course structure. So without further ado, I'll let the authors begin. Jeff Saltz, take it away.
Hi, everybody. I'm certainly very happy to be part of this webinar. To give you a little bit more context about my background, I've been at Syracuse teaching and doing data science, doing research in data science for about 4 years. Before that, I spent about 2 decades doing data science in industry, even before it was a field that had a name of data science. Today, what we want to talk about is a little bit about what we think data science is, how we describe it, how it's different from some other fields, such as statistics or computer science. We'll talk about some of the problems and areas that people focus on. We'll obviously talk about learning outcomes that a course or a program could do, and then we'll talk about some of the tools that might be useful to teach data science. And then we'll discuss a structure that might be useful for an introduction to data science class, and we're going to try to leave as much time as possible for Q&A. So if we go to the next slide, we can kind of start to dive in terms of what is data science. And you can see here that we can see that there's 3 main fields that people often kind of associate with data science. So there's mathematics, computer science, and then the domain expertise. Oftentimes in data science, there has to be a fair amount of programming that's done. You have to understand the statistics and mathematics behind it. And what's different of data science than a core statistics program, for example, is that you have to be able to put the problems into context of a certain domain. So that means either understanding that domain or being able to talk directly with the subject matter experts in that field. So it could be supply chain management, marketing, or whatever the case might be. So it really is kind of at the intersection of several different disciplines, and oftentimes people do view data science as a multidisciplinary field. So if we look at the next slide, we can kind of get a feel for how we think about data science courses or program even. And we have two key dimensions that we try to think about it on. So first on the horizontal axis here, you can think about the level of technical expertise, and we kind of include in that the mathematics and statistical skills that one has. And then on kind of going up on the y-axis there is the domain-specific skills. And while we show three different buckets, if you will, of programs, you can really think of this as a continuum. You can think about a course that is along this continuum, or in fact even an entire data science program that's on this continuum. And the data analytics focus, for example, is much more on understanding the domain and how to use data in that domain, and you're going all the way down on the other side, foundational data science. Focuses much more on the underlying algorithms, how to implement those algorithms, and then the applied data science is a little bit in between, which has some of the applied areas in terms of math and programming skills, but also has some of the area focus in terms of domain knowledge. So, I think as different people think through what is data science or what is a data science introductory course, you can think about upon these two dimensions. There's not a right and a wrong. It's just where do people feel comfortable within their school, for example, how to apply their focus. We can kind of dwell a little bit more into their flavors by looking at the next slide. And we can see, Jeff Stanton's going to talk a little bit more about these rows, which we can think of as being learning outcomes or kind of what we want to achieve within a course or a program. And then I have, again, these three different flavors showing kind of where there's a focus. And so, to kind of highlight a couple rows, you can see in the middle there developing new machine learning algorithms. Clearly that's important for some programs, and that would be part of foundational. And as you can see, it's not really a key focus within either of the other two, where being able to collect, clean, and organize data is a fair focus for all of them, but maybe a little bit more kind of a heart of the program with an applied data science area focus. And then, communicating the findings, that's clearly very important for, the side which is focused on data analytics and being close to the business client, if you will. The bottom one, obviously, is integrating ethics and privacy, and we view that as something that's foundational in nature that should be integrated within a course, not a separate course. And we'll talk a little bit more about ethics as we go through this webinar. So maybe jumping to the next slide, we can kind of see here that we can think about also another way to think about these different types of data science courses and programs is to think about the roles that a graduate aspires to. And so there's a lot of different roles, and these are not well-defined roles, so other people might call these types of areas different things, but there's data engineers, which really focuses much more on how to kind of collect and munge the data. There's a data business analyst, which understands or tries to understand what the business is trying to do and try and translate that, if you will, into a data problem that a data scientist could work to solve. A data science architect works with how to store and retrieve information. And then the data scientist perhaps is that general purpose person that can kind of span the full spectrum. And so, there are other roles, of course, in different organizations, whether in industry or academia, call these names slightly differently perhaps, but it's still helpful to think about what roles your course or your program is trying to address. I guess if we take a look at the next slide, we can also see that, I don't really want to spend a lot of time on this, but I think everybody knows there's lots of jobs for lots of different roles. So it's not like some of the roles don't have jobs and some of them have more jobs. Pretty much this whole field has a huge demand for it from industry, and they kind of span the full gamut of the roles that I kind of covered before. Some of them have different names. So head of machine learning, I would consider that a data science role, for example. So if we take a look at the next slide, I'm going to now pass it on to Jeff Stanton, who can talk a little bit more about the learning outcomes.
Hi, everybody. Thanks a lot, Jeff. I appreciate everybody joining us for this webinar. a little bit more background on me. Like Jeff Saltz, I started in computer science and somehow ended up in psychology, but with a pretty heavy focus on methods and statistics. So I tell my psychology friends that I'm a reformed computer scientist, and I tell my computer science friends that I'm a social scientist gone rogue into this new area that we call data science. And a little footnote about this particular slide, the image on here is actually some of the student work from our most recent semester. Jeff Saltz and I teach an introductory data science course together, and I have the undergrads in my section, and they produced this, one of them produced this as part of their project. So next slide, I want to talk about learning outcomes, and I'm breaking this into a couple different pieces. These are learning outcomes that Jeff and I consider essential for all data science students, and I've organized them into 4 broad categories, but you notice that I have ethics as a centerpiece there, and that's because we believe that it's important to infuse ethical thinking into the learning goals of a course in data science at each stage. There's been a lot in the news lately about privacy, and in Europe they're implementing the general data privacy regulation, and so these kinds of concerns are more critical than ever for this field. So in terms of these 4 big buckets, one up in the upper left, assessing user needs, it's really important to be able to work with data users to develop competence in the problem domain and assess what people need in terms of analysis and reports and so forth. In the lower left, managing data includes collecting, organizing, doing metadata, managing larger data sets. Cleaning and screening is, or what Jeff referred to before as munging, transforming variables, very important skills for all. In the upper right-hand corner, analysis and visualization are areas that I think many people associate most closely with data science. And here it's important to know what kinds of techniques are applicable in what types of situations. And then finally, in the lower right-hand corner, communicating is kind of a core skill, we believe, because being able to take the results of analysis and visualization and use those to influence decision makers and others about what the data are trying to say. That's another core skill. So on the next slide, we start to go into learning outcomes that would be unique to a more applied data science program. So here we have more in-depth focus on software tools, on integrating multiple data sources. This would be an intro course in a program that would be focused on producing graduates who would be data scientists, architects, or engineers. So there has to be an increased focus on being able to use inferential statistics properly, and acknowledgement of the fact that the data sets that graduates are going to be using are likely to be much more complex and larger, as will the projects themselves. So larger data science projects require multiple people to coordinate their work, and so that type of project management also becomes more important in an applied data science program. And then in the next slide, we talk about foundational data science programs. And here, this is preparing graduates for work as machine learning developers, as data mining researchers, or big data engineers. So these additional learning outcomes really reflect the focus of a foundational data science course on the development and performance testing of algorithms. So foundational courses would tend to drive students towards more competence with programming languages, more use of power tools, perhaps more cloud-based expectations that are on them. Now, let's see here. I think I was going to ask Susanna if we were going to do another poll at this point.
Yeah, that's right, folks. It's time for our second and final poll of the presentation. We have another question here that's right on your screen in front of you. What would be your first choice of software when teaching data science? And hey, folks, if you have another another tool that you'd prefer to use, you can put that in the chat box at the right of your screen. That'd be interesting to see if there are any other emergent tools. We'll give you another couple of seconds to lock in your answer. I'm seeing people say SPSS. Oh, here's a good comment. I know both R and Python, but it would depend on the population taking the course. It depends, right? Lots of SPSS folks on this particular audience here. Well, Camille, I guess we want to wrap up the poll. What do we have here? Oh, fantastic. Lots of R, some Excel. Then a lot of comments coming in from the audience as well, which is great. All right, well, we're about to talk about these tools in a little bit further detail, so I'll let the presenters get back to it.
Sure. Could you bring me to the next slide, please? So someone made the point in the comments that tailoring your choice of software tools to the type of students that you're teaching and your learning goals, that is really important. So this starter toolkit that you see here refers to some opportunities to engage with introductory students who may not have a deep mathematical background, and also for courses that don't necessarily have a very strong statistical underpinning to them. And in particular, draw your attention to some of the infographic tools. You know, for students without a strong mathematics background, using storytelling with data is a really powerful way to get students to engage. And so I'm sure you've seen these infographics. They're a mix of visualizations and data presentations, all trying to tell a story about some particular area. In a more business-oriented context, a lot of students will have basic competency with Excel, and there's an awful lot that you can do with Excel or one of the other equivalent spreadsheet programs that is quite relevant to data science, and so that might be a reasonable choice as well. And then in the third line here, there are some of the stronger visualization tools, and these are used in enterprise contexts. So to the extent that you would integrate one of these into a course, that would have the added benefit that it might be a skill that the students could put to work after they graduate or during an internship. On the next slide, I talk about power tools. Python didn't get very far in our poll, but that's okay. It is considered to be second only to R in terms of its popularity for data science courses. You're probably familiar with some of the differences and similarities. Both are full-featured languages with add-on libraries, and they extend the basic capabilities of those languages with the add-on libraries. In Python, there's a package called NumPy, which is considered one of the most fundamental scientific computing packages for Python. And then R, of course, has more than 10,000 different packages available. It was really designed to be the main language of statisticians and professional data analysts. Both of these languages have the advantage that they can be deployed on enterprise-wide solutions. So it's something that a student can take with them into the workplace and use for a variety of different purposes to create applications that have statistical or data analysis underpinnings. And then on the next slide, I talk about some additional power tools. So to the extent that a program focuses on working with truly large data sets or integrating dynamic data sets where information is flowing in all of the time, Some familiarity with web services for big data would be a really useful thing to have. You could really spend a whole course or even more than one course on these types of tools. So in an introductory course, it might simply be a first exposure. Down at the bottom, I've got a list of different machine learning platforms, thinking about what Jeff and I call foundational data science courses, where the development of machine learning algorithms and testing of their performance, if those are important goals of a course, then some exposure to these more sophisticated machine learning platforms might be very useful. And then I guess I would just conclude my section with a note that SPSS and SAS, of course, are long-established commercial tools most closely associated with statistical analysis, and those two could be good choices, particularly for a course where statistics was more of a focus. And with that, I will turn it back over to Jeff Saltz to talk about the course structure of a data science course.
Thank you, Jeff. So what I want to try to do here is help give people a feeling of the content that could be in an introductory data science course. So if we take a look at the next slide, we can see that Jeff and I kind of created two columns here, essentials and then some options. And really even what goes into each bucket is up for interpretation, but clearly there's some foundational pieces that we feel are important for an intro course, some basics in terms of reading data, transforming it, munging, which we talked about before, doing some descriptive statistics and visualization, but then it's also important, I think, to show the power of data science by doing some maybe perhaps machine learning or natural language processing, for example. So as I go through some of these different sample course modules, if you will, I think it's important to mind that this is our view of what it could be. There's obviously a lot of different possibilities. And the way we view it is these are kind of, it's a survey course to give students a broad view of the field. And as Jeff said, across a number of different areas, you could spend a whole semester on a lot of these. So, I'll talk about visualization. You could spend a whole semester on visualization, for example. So if we go to the next slide, we can see that there should be obviously a focus on reading, transforming, and some munging data. So what I mean by munging data, we've used that a few times, and that's oftentimes a significant time for a data scientist, and that's getting data perhaps from multiple sources, taking a look at the different columns or attributes, trying to figure out how to combine different data sets into one, perhaps cleaning it through various statistical techniques. And then understanding some basic structures as well, whether it's a series of vectors or a data frame, which are more like grids. I think those are important. And then I note here that there's several different formats. So Excel, CSV, people are probably familiar with as well, which is kind of a standardized way to share information. JSON is another one that I'll mention very briefly, and that's JavaScript, and that's really about accessing web data, and that's kind of an emerging standard in that field. So this is kind of one area that is foundational, and you can kind of use this throughout a course to practice, whether it's visualization or machine learning or whatever the case might be. So if we take a look at the next slide, we can kind of see that, in addition to kind of the programming side, if you will, there's a statistics side, which is important to give a foundational. And in some courses, there's no prior knowledge required in terms of stats, and in other courses, there is. So the course that Jeff and I teach, that Jeff mentioned before, we allow students with a pretty wide background, and so we kind of fill in the foundational components of both descriptive and inferential statistics, and that helps people put in context the data that they're looking at and the data sets that they have access to. If we go to the next slide, we can see that visualization is kind of a key component. I mentioned ggplot2, which is one of the 10,000 R packages that Jeff mentioned previously. There's a few that are very widely used. This is one of them. So if the course was in R, then this would be a package you would use. If the course was in a different programming language or Excel, you'd use obviously an analogous tool to help do that. But the goal here is help students understand how visualization can either augment or enhance the insight that one can generate either through statistics or machine learning algorithms. If you take a look at the next slide, you can see here's kind of a very simple example of something that can be built in R pretty simply, and we just wanted to point out exactly where Syracuse was in case people were curious. But it shows the power of how you can generate a data set and visualize it, right? So it's not just about statistics, it's about giving people a feeling for different areas that might be spatial in nature as well. So if we take a look at the next slide, we can kind of then maybe focus on machine learning. At a high level, there's two areas of machine learning. Jeff and I cover them both in our introductory course. So there's unsupervised, where the algorithm uses all the data. And then there's supervised learning, which basically you divide it up, you give kind of an initial training data set, which you kind of let the algorithm know the answer, and then you test it on a subset of the data that you've held back. And so there's examples of both of these. Talking about R again, so these are example libraries that are available. Those are additional libraries. So whether it's clustering, support vector machines, neural networks, a lot of other ones that we didn't list here. There's libraries that's part of the powerful nature of R and other programming languages, is that you don't have to implement a neural network now to use a neural network, but you do have to understand the drivers of how it behaves. So that's another difference between the applied data science we were talking about and foundational data science we were talking about before. So finally, if we go to the next slide. So the last area I'll talk about in terms of content is text. So all of the previous slides have really been focused mainly on structured data. Text mining and natural language processing focus on textual-based or unstructured data. I think it's helpful for students to understand the strengths and weaknesses of both, and also, just understanding the different types of data that exists. And just to highlight the difference between text mining and natural language processing. So text mining really does statistics on the text, where natural language processing is really trying to help parse the text and understand which are the verbs and adjectives and look at the grammatical structure of the actual text being analyzed. So it's two approaches, and they obviously can be complementary combined in the analysis of the text passage. This next slide we have talks about ethics. So I have it last, but certainly not least, and it's something that really should be integrated within a course, not one module kind of at the end, not a separate course. We feel strongly that it's important to have people kind of understand the context of the work they're doing. I won't go through all these, obviously, but maybe one that's here I'll talk about is the model fair? So that's really talking about bias. And bias can come across in many ways, and oftentimes it's bias in the data. And so the model is accurately representing the data, but the data has bias. So just understanding the data, what's in the data, might the data be biased, is a good conversation for students to think about as they maybe work on a project they're working on. Model transparency, that'll be the next one I talk about. Right underneath that, and both of these are model-related challenges in this graph, is that sometimes it's important to explain how the model works. And if that's the case, some of the machine learning algorithms are more applicable than others. So if you need to explain why somebody was rejected or accepted for a loan, there's some algorithms that will make it easier to do that, and some that'll be much more difficult for the data scientist even to explain to a branch manager, for example, about what's going on. So these are some of the questions that students can think about, that when you're teaching an introductory course, you can kind of introduce these throughout the semester as you're working on different tasks. So I think we'll wrap up by kind of looking at the next slide and kind of, if we had to kind of summarize the key points here, I think the first thing is to understand that there are really multiple flavors of introductory data science courses and data science programs, really, that we've talked about throughout this webinar. And I think that's important to think about, that there's one not right answer, but it's important to think about that as you're thinking about the course you'd be teaching. How does it fit into that spectrum? And then the other part is that almost kind of complementary to that, ethics should be infused within the class, and effective communication and data management and general analytical skills should also be there, independent of the flavor of data science course that you decide to endeavor to teach.
Well, all right. Thanks, Jeff and Jeff. That was a terrific presentation and very informative. You managed to pack a lot in just a short amount of time. But it looks like we're right on time here, and some of you have been submitting questions. So I'd like to encourage you to keep submitting those questions there. We are going to use the rest of our time today just for Q&A. So please keep those questions coming in on the right of your screen. We've got that chat box. And also we're on Twitter. You can use the hashtag SageTalks. We'll be looking for any questions there. If there are any questions that we don't have time to get to today, Jeff Saltz and Jeff Stanton have kindly agreed to address them later. We'll have a follow-up blog post that we'll email to you. And I just see a few questions coming in about if we're recording this or if we can have a copy of the presentation. And yes, you can. In a follow-up email, we will send this recording. We'll send the questions that our presenters didn't have time to get to today, and we'll send a copy of the slides as well. But please keep those questions coming in, folks. So I would like to address my first question to Jeff Stanton. And I will try to switch off my questions as gracefully as possible between the two Jeffs. Obviously, I ask you to bear with me if there's a little bit of confusion, which particular presenter I mean. But let's get right into it. Jeff Stanton, we've gotten a few questions just about ethics, and you both touched on that in the presentation. And we think, you know, more than ever, it is time to keep those ethical considerations in mind. And folks are asking, what are the actual safeguards and considerations that people should have in place when doing this sort of research? Are there any specific examples that call to mind from past research?
Sure. So this is a hot area right now because of things that we've heard in the news, and I won't call out any one particular company or organization, but there have been many examples, we'll say, that of instances where users who have contributed data, so consumers who have contributed data into some data source, have found that their data is used in ways that they didn't expect. And so from a teaching standpoint, I think one of the valuable things that an instructor can do is to walk a student through a case study that shows how those types of situations evolve. And I think, as with many technological developments, these things creep up on us. The technology, the invention moves more quickly than the public policy does. So if you think about it, the general privacy data regulation that just came out in Europe, it's been kind of a long time coming, given how long the internet has been around and how long that we've had people collecting data at a massive scale. So there isn't any one type of protection that will work, but it's important when engaging with students that they understand the origins of the ethical issues that crop up, and that they understand what options they may have to contribute to doing a project in an ethical way.
Okay, thank you. Jeff Saltz, if you have anything to add, feel free. If you'd like to move on to the next question, that's fine too.
Well, yeah, maybe I'll just, because it is such an important point, I'll just add, I think, I certainly agree with everything that Jeff Stanton mentioned. And I think the only thing I'd add is, as you're teaching a class or going over a project or a case, whatever the situation might be, I think it's helpful to kind of have students think about what are the ethical questions that one should be asking. And just that conscious thought process can help uncover things. As Jeff said, the field is still emerging, and so it's not really kind of saying, here's what you should and shouldn't do. It's more about making sure it's a conscious thought process that one can think about, or what are the right questions I should be asking as I'm a data scientist working on a project. And the best way to do that is to start thinking about those questions as you're a student working on a project.
Thank you. Okay, Jeff Saltz, we'll keep it with you for this next one to begin. What ideas do you have for any data science-based projects that one could integrate into their course? Do you have any specific examples of projects that you have your students do that really help them to learn about these concepts?
Yeah, that's a great question. I think Jeff and I both think that project-based learning is a key component of a data science class. It gives students hands-on practice. And it's one thing to kind of do it in the small with a small assignment, but it's another thing to have students trying to struggle with what algorithms should I use, what type of machine learning might be useful, what type of actionable insight would be useful to a client. So I think providing that opportunity for students is very useful, whether it's an individual project or a group project, that might vary, but allowing students to really think through and how they present the information as well. So as we talked about, a key part of being a data scientist is being able to communicate to end users, whoever those users might be. And so, you can use a project as an opportunity to have students explain their results to people that don't understand data science terms. That could be a challenge to many students. And so the only way to solve that is to practice. And so I'm a strong believer in giving projects. In terms of data sets, there's lots of data sets that are available in different locations depending a little bit on the type of course you're teaching and what department you're related to. So obviously if you can make it domain specific to the department that the students are most interested in, that could be helpful. I've been in courses where students can pick their data sets. I've been in courses where I've assigned data sets. One great place to look for data sets is Kaggle, which is a site that's done where people submit data and some students try to work on answers. So you can do that as long as you're aware that students also look there for potential answers. But there's lots of different data sets. There's also government data sets that are available that you can assign as a problem to work on as well.
Oh, thanks. And would you just say the name of that website again one more time?
Yes, Kaggle, Kaggle.
Okay, that's great. Just a follow-up question, actually, that maybe Jeff Stanton you could take, is specifically about client-driven projects. So if you have a client-driven project that you might do in class, have you typically had to engage in data agreements, and do you have templates or checklists that you've created to get through that process as efficiently as possible? So kind of two parts to that, whether you do client-driven projects and how you get through that as smoothly as possible.
Yeah, we have definitely done client-driven projects. They tend to be later on in the curriculum because they are more capstone-oriented, a kind of summation of a student's learning and experience. And it's hard to do them earlier in the curriculum because students don't necessarily have the full skill set to engage properly with a client. I think the watchword, if you're doing this in the university context, is the watchword is preparation, because you may need to work with your legal team for your university in order to understand what type of agreements that you can enter into as a faculty member. And particularly thorny is you can't, in many instances, you cannot force a student to undertake an agreement as part of their coursework. So you often will have to present some sort of alternative to entering an agreement, which of course can really put a monkey wrench in your planning for the project. So if you prepare in advance and you get some consultations with your university's legal advice, sometimes you can figure out what you need to do to prepare in terms of forms and agreements and how students will be engaged.
All right, thank you. I'm getting a lot of questions related to resources, books, videos that you would recommend in helping build those data science skills. Jeff Saltz, do you have any recommendations, perhaps even for books that you would recommend?
Well, yeah, there's one book that Jeff and I particularly like that we think does obviously capture what we think is important. We use it in our course. We've used it for a number of semesters. And it really focuses on the applied view of what data science is. So it's very hands-on. It's focused on R. And the goal is to help students understand both the practical as well as the conceptual, how does this all fit together. So it's we think it provides a nice bridge for students that are trying to work through R, but also have the context about what they're trying to do in R.
Okay, any other general resources you want to recommend?
Jeff Stanton? I don't know. I mean, so first of all, there's lots of different sources on the web, for example. So I don't want to say that there's any that are better or worse. I will say that, there's certainly videos that we've done in conjunction with the book that are useful to help students in that way. And there's other resources as well that can be used depending exactly how you're trying to focus the intro course.
I would throw in something additional here. So there are a couple web resources like Stack Overflow and R Bloggers where people work through actual code examples of problems that they've solved. And there's a remarkable number of these out there for almost any kind of situation that you can imagine. And so one of the key things you need to do as an instructor is figure out what your attitude is towards having students borrow code fragments from other sources. And it's in my view, a fact of life in contemporary software development that borrowing code is something that you do in order to make a project go faster. So you don't necessarily want to completely outlaw it, but you have to also have a way of making sure that students are learning the material and not simply cutting and pasting. So the resources with respect to code are kind of an interesting conundrum for instructors.
Yeah, thank you. We just received a great question that goes like this. I teach data science integrated into my intro comparative politics class. How do you begin with students who arrive without any prior knowledge? And I think this question could probably apply to anybody who's integrating data science concepts into a non-data science specific course. How do you advise that instructors handle those students? Jeff Saltz, I think we're on you.
Sure, and I think I guess first of all, when we teach data science, we have a range of students, and there's a good number of students that we teach both at the undergraduate and graduate level that have no prior experience in data science and no prior experience programming, and really no prior experience even in statistics. And I think the key is to provide the context and foundation upon which they can build upon. And I often tell students in the first lecture that yes, somebody that's been programming before in Java, for example, if they have a computer science background, has a little bit of advantage, but they also have to unlearn some skills. And so I kind of view it as, there's pros and cons to what experience you have, and you might have more domain knowledge expertise if you're coming in with no data science expertise. And if you have more programming expertise, you have to kind of think about things differently than you did when you were doing Java programming to really leverage the power of R. And so what I would say is that if you kind of go through a course like we've done in our book outlines, then you really can start at the base level and build up from there so that students from all levels, really can understand what data science is and can practice it.
And I would add that we've occasionally had success in having two courses work together. So the kind of introductory data science course that Jeff and I teach, students in that course can learn from working with students who are taking other courses in domain specialty areas. So it's possible to get two courses worth of students to work together on projects for the mutual benefit of all the students. You really need some cooperative faculty and department chairs to make that happen.
Yeah, absolutely. Just a follow-up question to that, Jeff Stanton. How would you teach to somebody who is scared of data, which we all know is a thing that happens, that some students just arrive being completely intimidated by working with data. How do you handle those students?
So in our introductory course, we really do start out quite gently and without a lot of expectation that students have a deep math background. And in fact, that's the stumbling block that I've found, that a student who's had difficulty in math, whether in high school or previously in college, assumes that they won't be able to handle some of the concepts and ideas and skills in data science, and I've not found that to be true. So it's often more just getting the student over the hump that they can do it, and that their previous experience with math is not an indicator of how well they'll do working with data. That's really the key.
Are there any specific things that you say to those students, or things that you give them to help them feel empowered to do these things on their own?
I always start by saying if you can add, subtract, multiply, and divide, you're going to be able to do fine in this course.
That is fantastic advice, and I'm sure we'll all be using that in our courses going forward. Okay, Jeff, Saltz, back to you. Just in terms of student engagement in general, that can often be a stumbling block with this type of course. Beyond just being intimidated by math like we were just talking about a moment ago, when it comes to issues of engagement in general, do you have any tips or tricks that you'd like to impart to our audience on how you keep those students engaged and motivated?
Yeah, I think that's a great question, and I think one of the things we do is we provide what I like to call our very small mini cases, where I discuss a certain situation where data is available, or where there might be a problem available, and have students collectively work through how they would approach it. So rather than going through the details of the actual coding and the analysis, keep it more at a conceptual level, so we can start early in the semester and have these conversations about what data would you need, for example, if you're working with an airline and trying to overbook your flights, but what's the right amount of overbooking to do, and work through that entire problem, and why, what is a data scientist's role in that situation, and what data would the data scientist use, and how would that be leveraged by the organization and things. And so I think you can have these conversations so that students get the conceptual view of data science as well as the hands-on view, and I think that keeps them pretty well engaged, or at least it helps keep them engaged.
Any other comments, Jeff, Stanton?
What I liked about Jeff's example is it ties data science to an experience that students may have personally had, and so they understand the dynamics and the implications of it in a very personal way. Another of the examples that the other Jeff uses in teaching is a vending machine. So what kind of data is thrown off by a vending machine, and what can you do with it, and that every student has used a vending machine of one type or another, so they understand very intuitively what's going on, and that helps to build a connection to the problem space.
Okay, thank you. We just have a question about Python versus R, and I don't know that we have to pit them against each other necessarily. You talked a little bit about some of the differences and similarities. Would you just go into a little bit more detail about what each tool does really well, and what, when Python should be your first choice versus R? Jeff, Stanton?
Sure. Python was developed as a general purpose language, and it was very intentionally developed to be easy to understand with respect to the syntax. A lot of early stage computer science students get stuck on syntactical issues. So Python is quite easy to understand and easy to learn as a first language. But because it was general purpose in nature, it was really built to create user interface-based applications, either for the desktop or the web. And being able to use a language like Python for prototyping, it wouldn't necessarily be your first choice for a high-performance application, but to be able to prototype a new application is something that it can do as a general-purpose language. The strength of Python is in the wide range of additional packages that you can add on, or libraries that you can add on to extend its capabilities. And it's almost coincidental in a way that extending its capabilities in terms of statistics, analysis, visualization, machine learning, and so forth, that has come along, because the language wasn't initially designed to be focused on that. So on the other hand, R, which is an open source language based on a previous language, which for some reason was called S. I think I would have gone the other way in the alphabet, but that's okay. So R was developed from the beginning to be a statistical language, and it has all of the tools that a mathematical statistician needs to do in order to create new test new ideas in statistics. So its orientation towards statistical analysis was sort of baked in from the very beginning. So it's great from an analytical standpoint. You wouldn't build an enterprise application in R. You wouldn't, even though R does have some web capabilities, it wouldn't be your go-to in order to build a web app. You can't run R on a phone or on a tablet or anything like that. It hasn't been ported to those platforms. So it really is quite a specific language focused on statistics and data science. So I hope that gives a little bit of the flavor of the difference between those two.
Yeah, thank you so much for that. Jeff Saltz, back over to you. What do you think, if you were coming up with some key competencies for students who were maybe just becoming researchers themselves, not necessarily taking a dedicated data science course, what are some of the key competencies in actually becoming a data scientist, if you just had to boil it down to, 3 or 5?
Wow, that's a good question. I think, the key competencies of a data scientist, I think probably if I thought through it, I'd go through the life cycle. So I think the first thing I'd point to is being able to understand and explain and figure out what the question is you're actually working on. So, working in the domain space and being able to either talk to subject matter experts or be a subject matter expert, but really understand what it means to think about the data and generate actionable insights. So that'd be one thing. And then I think a second skill would be to be able to use some set of tools, and we talked across a variety of different tools, but to be able to use some set of tools to do some of that analysis. And so, if we're talking about an R, it's being able to use R to do machine learning on it. And maybe if I had to pick about the third key aspect, and that would be to be able to integrate and munge data. And again, we use that word munge, but that really is a key aspect of being a data scientist. That would be, understanding different data fields and cleaning up data, because in the real world, data is not always clean. It's not always consistent. There's empty fields. So what do you do if a field is partially complete and partially blank? So being able to understand that key concept. So, you really have these 3 different parts. So one is thinking about it from a client's perspective. How do you, what is actionable? Second part is thinking about how to clean that data and access that data and merge that data. And then finally, being able to use different algorithms to generate insight that, some traditional, just basic descriptive statistics couldn't provide that insight.
Fantastic. Jeff Stanton, anything to add there?
I would add one thing, which is more about a student or graduate or a professional's kind of attitude. So when you present an analysis, which is the end result of a whole long chain of things that Jeff just described, you have to have a certainty of the provenance of what you're doing, that the data has been transformed in sensible ways, it's been treated in analysis in ways that respect the assumptions that are necessary for that particular kind of analysis, and that at every stage of the way you're sure that what you've got in your hands is right, and that requires a kind of persistence, level of conscientiousness that I think is unique in the data professions. If you get to that final presentation and somebody finds an error in what you're presenting, it undermines your credibility, which is something nobody wants to be in that uncomfortable position. So having that kind of attitude or approach as a key thing that we help to develop as instructors, we help our students to develop that. I think that's really important.
All right. Thank you so much. I think this will be our final question here, and I'll just throw it out to both of you. So if one of you has a specific comment, feel free to jump in. We've gotten a few questions about your book. One specific question is what sort of minimum requirements somebody should come to the book already having had, or whether it's suitable for somebody who's completely a beginner. I know the answer to this, but I'm sure they'd love to hear it from you all. What do you think? Is your book suitable for beginners?
This is Jeff Stanton. I sure think it is. I'll just give a little bit of the origins of the book. Originally it was many, many years ago now, we developed a kind of massive open online course. And the first few chapters of this were developed in draft form for the users of that so-called MOOC. And so we had no idea who was going to sign up for that thing and what kinds of skills they would bring to the table. So we really started with the basics. What would you say, Jeff Saltz, about where it went from there?
Yeah, I mean, we've certainly iterated over the years to get to the point we're at now. But I think to get back to that key question, I think the only thing that a student needs is some interest in data science. We don't really assume a programming background. We don't assume a strong math background, and we don't really we try to have it be open to everybody. And even the writing we use to try to make it easy to follow. So hopefully we find that people can use this independent of the background and have a variety of different backgrounds and still have it be useful.
Okay, thanks so much to both of you. That's a terrific answer. And I think we're going to leave it there for our presentation today. So everyone else, you'll notice on the screen in front of you here, you have a cover image of the Jeff's book. We are offering a promotional code on the screen in front of you. It's DataSci. You can see it right there on the screen in front of you. You can use that on sagepub.com for a 20% discount on this book for the next 2 weeks now. And as always, if you are an instructor and you're considering the book for use in your course, you can request a copy at sagepub.com. Okay. Well, thanks everybody for joining us today. Special thank you again to authors Jeff Saltz and Jeff Stanton. And, thank you to the behind the scenes team who assisted with today's webinar. Really appreciate that. Everyone, please be on the lookout for an email that includes a link to view the entire webinar. It'll also have the slides as well. So stay connected with us for more information about upcoming webinars and follow us on Twitter at @sage_methods. Thanks so much, everybody. Have a great day. We'll see you next time.